Alright, so today we're going to go over our Unit 1 test review. My voice is still a little hoarse, so I probably sound a little weird. So I'm going to try to keep talking to a minimal, but still help you out with how to do the problems. So number one, Juan completed the table below. What mistakes did Juan make? So he said that -3/5 was a rational number and an integer. 5 was a rational number and an integer. 0 is a rational number and an integer. 0.2 is just a rational number. Alright, so if we think back to our chart, we have retro iguanas waving numbers. So rational numbers are your fractional parts. Then integers are negative, 0, and positive numbers. So they don't have any fractional parts. So that's the mistake that he made, is that an integer, -3/5, can't be an integer. So G is our answer. Number 3, Anne Marie had a board that was 8 3/5 meters long and 7.5 meters wide. She cut off a piece that is 8 meters long. Cut is a keyword too. Anne Marie then cuts the remaining section into 3 equal sections. What is the length of each remaining section? Well, I think it helps if we draw a picture. So we draw a picture, we're going to label it. So it's 8 3/5 meters long, and it is 7.5 meters wide. So she cuts off a piece. So that means that she cuts it off. So there's our little cut. This is 2 9/8 meters, or 9/10 meters. So in order to do that, I need to take our length and subtract that much. So I'm going to do 8 3/5 minus 2 9/10. Alright, so I need to convert that to a mixed number, so I have 5 times 8 plus 3 is 43/5. Minus 2 times 10 is 20, plus 9 is 29/10. Well, when I'm subtracting numbers, I have to have a common denominator. I can multiply 5 by 2 and 43 by 2. So I get 86/10 minus 29/10. And that gives us 57/10. But then the next part says that he divides it into 3 equal sections. So I actually need to divide this number by 3. So I don't want to convert it yet. Well, when we divide fractions, first we need to make sure that all of our numbers are fractions. So we can put any number over 1 to make it a fraction. Then we keep the first number the same. You flip the sign and multiply. So you flip the second and multiply. So we keep the first one the same. So 57/10 doesn't change. We change the sign to multiplication, flip the sign of the second number. So we have 57/30. So 30 goes into 57 one time with a remainder of 27/30. So that is how long the remaining pieces are. So if we just had looked at this, first we cut it off to 2 9/10. Then we had to divide the rest into thirds. Right? So after we cut off 2 9/10, we had 57. Oh, I'm going to do it on the 57/10 left. And we divided that in 3. So each of those parts are 1 and 27/30, which I think can reduce down to 1 and divide by 3, 9/10. 1 and 9/10. Number 2, so make sure that you're doing these on the right problems. To take a screenshot of the pictures, it's easier for me to do them when they're side by side. So apples cost $1.20 per pound at the store. She buys 3 1/3 pounds of apples. Carrots cost 66 per pound, and she buys 2/3 pounds. If she pays with a $10 bill, how much change will Miss Case receive? So let's first talk about apples. So apples, she pays 1.20 dollars per pound for 3 pounds. So if it's per pound and we buy 3.5 pounds, or 3 1/3 pound, that means we would need to multiply those numbers. I like to multiply with fractions, and so there's two different ways you can do this. You can convert 3 1/3 to a decimal and multiply, or you can convert 1.20 to a fraction and multiply. So that's what I'm going to do. So 1 so 0.20 is 1/5, because it's 1/5 of a dollar, times 3 1/3. So I'm going to convert these two improper fractions. 5 times 1 is 1, plus 1 is 6, 6 over 5, times 3 times 3 is 9, plus 1 is 10, 10 over 3. So 60 over 15, which is 4. She spends $4 on apples. Alright, well now we're going to talk about carrots. So for carrots, she pays 0.60 cents for 2/3 of a pound. So I'm going to convert 0.60 to a fraction, which is 3/5, times 2/3, which gives you 5 over 15, which is 1/3 of a dollar, which is, 33 cents? So when we add those together, her subtotal, or her total, is $4.33. But that's not what the question is asking for. To find change, you take how much she paid, which is $10, and you subtract how much she bought, which is $4.33. So your answer is $5. Oh, you can barely see that. Let me redo that. It is borrow from the 1, borrow from the 10, borrow from that 10. 10 minus 3 is 7. 9 minus 3 is 6. 9 minus 4 is 5. 567 is how much money she got back in change. It says, complete the diagram below and fill in the miss and number section. Place some numbers below where they would go. Remember that rational numbers are all your ones that have fractional parts. So 10 over 2 is actually 5. Well, then we have 120, and then the rest are in good form. So our natural numbers, so 10 over 2 is a natural number. It's 5. 0, negative 2 is not a natural number. Negative 2 is an integer. 0 is a whole number. So I get those three taken care of. Negative 0.5. Remember, if it's any fractional or decimal part, it is a rational number, like 0.125. 100 is a natural number. Negative 2/9 is a rational. And 1/20 is a rational. Alright, number 5. A single school lunch costs $2.25. A week or 5 days of lunches costs $8. How much money would a student save if they bought the weekly lunch instead of a single school lunch every day? So a week costs $8. But if you don't purchase the week, right, then you're paying daily. So you have to do 5 times 2.25. I wrote 2. It's supposed to be a 5. Times 5. So we have 2.25 times 5. 5 times 5 is 25. 5 times 2 is 10, plus 2 is 12. 5 times 2 plus 1 is 11. We have 2 decimal places in our problem. That's how many we're going to have in our answer. So you're going to pay $11.25 daily. But that's not what the question's asking for. The question asks, how much money would a student save? Alright, so if they would have had to pay $11.25, but they buy the week for $8, that means that they would have saved $3.25. Number 6. Bill wants to buy school supplies. The table shows the price of the supplies he is going to buy. If Bill buys 3 packs of pencils, 2 packs of colored pencils, and 1 pack of markers, how much will Bill pay, not including tax? Alright, so there's a couple different ways you can do this. You can do where it's repeated addition, or you can do where it's multiplication. I'm going to show both the different ways for each individual one. So for the first one, the 12 packs, he buys 3 12 packs of pencils. So he buys pencils. He pays $0.75 each. $0.75 per pack. And he buys that 3 times. So that's the first way we could do it. We could also just add $0.75 3 times. I think multiplication is a little bit easier. 3 times 5 is 15. 3 times 7 is 28. No, 21 plus 1 is 22. There are 2 decimal places in my problem. That's how many are my answer. So he spends $2.25 on pencils. Alright? Well, he spends on colored pencils, which are $4.12 per pack. He buys 2 of those. So I'm going to actually just add those to show you can do it both ways. So remember, when you're adding decimals, you have to line up your decimal place. So 2 plus 2 is 4. 1 plus 1 is 2. Bring my decimal down. 4 plus 4 is 8. So that's how much he spends on colored pencils. Alright, and then markers he just buys 1 of. So he just pays $2.20 or $2.30. So we have to add all 3 of those together. Well, we have to line up the decimal place. So we have 2.30 plus 8.24 plus 2.25. And that will be how much total he will pay. Right, so after we add all those together, we get 4 plus 5 is 9. 3 plus 2 plus 2. Let me just put this in a box. 3 plus 2 plus 2 is 7. Bring my decimal point down. 2 plus 2 is 4, plus 8 is 12. He's going to spend $8, or he's going to spend $12.79 on school supplies. Emily had, on number 8, Emily has overdrawn her account and has a balance of negative $453.26. Emily has a check for $150 and another check for $263.48. That is she going to deposit. So I'm going to highlight all those numbers. Okay. What will Emily's balance be after she deposits her account? So remember, your bank account has a running total. So you add together all of your numbers in your bank account. So anything that you take out is going to be negative. Anything you add in is going to be positive. So she had a negative balance of this to begin with. But then she added a check. Remember, checks are her money that's positive value. And I need to line up my decimal place. And then she added another check too. Again, positive value. So checks are positive. Alright, things that she spends or if she's overdrawn are negative. And so when you add those together, 3 plus 3 is 6. 5 plus 5 plus 6, 16. 1 plus 4 is 5, plus 1 is 6, plus 2 is 8. But this doesn't make sense because $866.66 is positive, right? And it wouldn't make sense that she would be net negative either, right? This is the most common mistake that people make. They just want to add together all the numbers, okay? But remember, we can't add together positive and negative numbers. Anytime we add positive or negative numbers together, we have to, anytime we're adding a positive number and a negative number, we have to subtract them, keep the sign of the bigger number. So that is the most common mistake students make. So there's my negative numbers. Now I want to figure out what my positive number is. Well, to figure out how much she total deposited, I can just add 263.48 and 150. So her total deposit was $413.48. Alright, so I am adding these two numbers together. Okay, since I'm adding a positive, that's positive because the sign right there is not negative. It's positive. I'm going to subtract them. So I'm going to subtract 413 from the bigger number. I borrow from the 2. 16 minus 8 is 8. 4 minus 11 is 7. 11 minus 4 is 7. 12 minus 3 is 9. 4 minus 1 is 3. And then, so $39.78. So think back to our original numbers. Which ones were greater? Which number was greater? This positive number or this negative number? Well, negative 453 is greater than positive 413. So, poor Emily is still very negative in her bank account. So even her checks did not help her become positive. Fred listed some of his assets. What is Fred's net worth? Based on the chart below. So remember, net worth is where you add together all your assets and you subtract all of your liabilities. So I'm going to write that down. Net worth equals your assets minus your liabilities. So let's make a chart about what our assets are. Our assets are the banking account, retirement accounts, boat that is paid off, yes. So those are our assets. So we're going to add together our assets. So I have 50,000, 20,200, 12,500. So total assets, that's a 7. Hopefully you can tell that's a 2. 5 plus 2 plus 1 is 8. So his total assets are 82,700. Now, his liabilities. His liabilities are credit card. Let me get a different one. We're going to do liabilities in blue. His credit card, car loan, and mortgage. Remember, your mortgage is your house loan. So we add those together. So we have 53,000, 2,000, and 5,800. Three plus 2 plus 5 is 10. 60. So our liabilities are 60,800. So net worth is just where you subtract the two. So I'm going to subtract 60,000 from 82,000. Remember, you always want to subtract your liabilities from your assets, even if your liabilities are more. That just means your number is going to be negative. It is possible to have a negative net worth. Right? Remember, we talked about all the celebrities that make really poor decisions and how they owe too much, they don't make enough, things like that. So it is possible, but this person, Fred, does have a positive net worth of 21,900. Tori has 8.5 hours that she can talk on the phone per month. She looked at her cell phone bill for March and saw that she had already spent 3 3/4 talking to her mom, 3 hours talking to her best friend. How many hours could she have talked on the phone? How many more hours? So remember, if we start with a number, 8.5, alright, and she already spent, so that's like me saying I went to the store, I had $10, I already spent 3 on a Coke. So I subtract 3 3/4. Alright, and then she spent another 3 hours. So that's another subtraction. Alright, so first thing we want to do is we want to convert these numbers into mixed numbers. So we have 8 times 2 plus 1 is 17 over 2, minus 4 times 3 is 12, plus 3 is 15 over 4. We want a common denominator, so we can actually multiply this by 2, to get it to 4 to get a common denominator. So we have 34 over 4 minus 15 over 4. 34 over 4 minus 15 over 4 is 19 over 4. But we have to remember that's not our answer because we had to keep bringing down the -3. We can't. It's really hard to subtract more than one number at a time. So I wanted to subtract those two first. So we need to subtract 3. So I can change 3 to a fraction by putting it over 1. But then we need a common denominator. Well, I can get 1 to 4 by multiplying it by 4. So we have 3 times 4 is 12 over 4. And then we still have our 19 over 4. So when we subtract that, we get 7 over 4. 7 over 4 reduces down to 1 3/4. So that's how long she has left to talk. That's how much more she has left to talk. Daisy bought a DVD for $29.95. Sales tax in her city is 8.5%. Alright, so she bought that, 8.5%. How much will Daisy pay in sales tax? Alright, so let's just use common sense right here. My favorite thing to talk about is what's a logical answer. Is D a logical answer to only pay that much in tax? I think not. I don't think we're almost going to pay what our cost of our item is in tax. A is pretty unreasonable too, but that's a little bit harder for you to figure out. Alright, so we need to take, so remember that sales tax equals your subtotal, which is your cost of your items, times the percentage. But we have to convert that to a decimal. Alright, so our subtotal, he just bought one thing, so it's $29.95 times the decimal. So we have 8.5%, but we have to move the decimal 2 places to the left, which means I need a 0 right there, and we need to get rid of that percentage sign. Okay, so now I am multiplying by 0.085. So I'm going to do my work down here. 29.95 times, and remember we don't have to line up our decimal on multiplication, 0.085. So 5 times 5 is 25. The main thing we don't want to forget when we're multiplying decimals is this placeholder when we move down to our next. So we already did 5, so now we're working with 8. 8 times 5 is 40. 8 times 9 is 72, plus 2 is 76. 8 times 9 plus 7 is 79. 8 times 2 is 16, plus 7 is 23. I add them together, 5, 7, 5, 14, 5, 2, and I have 1, 2, 3, 4, 5 decimal places, so that's how many I need to have in my answer. So this number, but we have to remember that money only has 2 digits, so 2.54575. Money only has 2 digits, so we know it's going to be $2. Alright, so the 5 tells us to go up on the 4, so it should be 55 cents. $2.55 is our answer. Miss Somers had 20 pieces of metal that were all the same length. If each piece of metal was 3.5 inches long and you put them side by side, what would the total length of all pieces together? Remember, when we start with small pieces and we're repeatedly adding them together, I know these aren't perfect. Let's just imagine you do that 20 times. Alright, it's called multiplication. So we have 20 times 3.5. Again, we don't have to multiply. We don't have to line up our decimal. 5 times 0 is 0. 5 times 2 is 10. Don't forget this placeholder. 3 times 0 is 0. 3 times 2 is 6. We have one problem in our answer, or we have one decimal in our problem, and so that's how many we have in our answer. So it's 70 inches is our answer. Alright, I don't think there's a number 13, so we're going to talk about number 14. How much income tax would Jessica owe if she's filing under married joint earners? Just kidding, there's the 13, I just skipped over it. So, how much, we're just going to do 14, then we'll go back to 11 and 13 in a little bit. How much income tax would Jessica owe if she is filing under married joint filers and earns $52,000 a year? So remember, if she's married joint filer. So we only want to look at this bracket. So we want to know which one of these three does she fall into. She earns $52,000 a year. Well, that doesn't fall in that bracket. It falls in this one. So her percentage she's going to have is 0.15%. So we have 52,000 times 0.15. Because remember, we're finding 15% of the number. We're going to multiply them together. 0 times 5. 0, 0, 0, 10, 26. Alright, then we have our placeholder. 1 times 0, 0, 0, 0. 1 times 2 is 2. 1 times 5 is 5. So, add these together. We have 2 decimal places. She has 2 decimal places. She's going to pay $7,800 in income taxes. Okay. Let's skip to 11 and 13. Abby has her following assets and liabilities. Calculate her net worth. So, remember, net worth equals assets minus liabilities. So we have we have to add up our assets, which are 5,000 plus 350, which is 5,350. Minus our liabilities. Liabilities are 60,000 plus 22,000, which is 62,200. So realize this, that her liabilities is bigger than her net worth. Alright, so her net worth is going to actually be negative. So when we're subtracting a bigger number, we actually have to take the bigger number, and that's the one that goes on top. And we subtract the smaller number. Well, if you're supposed to be subtracting the bigger number, the number is going to be negative. So we know, and I'm going to write it above it because I'm running out, that her net worth is negative already because we are subtracting a bigger number. So now we just have to figure out by how much. So we have borrow from the 2. 10 minus 5 is 5. Borrow from the 2. 11 minus 3 is 8. Borrow from the 6. 11 minus 5 is 6. So her net worth is negative $56,850. And then our last problem that we're going to do, and then we're actually going to practice putting it into a griddable. Solve the expression using PEMDAS. So we have 125 minus 78. So remember, parentheses are first, so I'm going to solve that first. 125 minus 78. So 47 times 2 minus 4. Our next one we're going to do is we do parentheses, exponents, then we do multiplication, division, whichever one comes first. Remember, whichever one comes first is the order which you do it. So we have 47 times 2, which is 94. And then you have to bring down the minus 4. Minus 4 is 90. Okay, so that's how we solve the expression. So remember PEMDAS. Now, remember when you're gridding it on a griddable, you don't want to put it right there. That is bad. That says 0.94. So what you want to do is you want to make sure you have it in the tens and the one spots. You want to circle really nicely. Okay, it's not really necessary to put the 0.00, but you can. Alright, and it'll help you that way. You know not to put your answers there. Alright, that is it.